Hello. Today, we want to talk about intercepts. So our goals be able to find the x and y intercepts of a function or some formula you're given, and also be able to identify the x and y intercepts of a function's graph. So first, let's talk about what intercepts are. Okay, so let's go down here on the right and talk about the x and y intercepts. So the x-intercept is the point where the graph crosses the x-axis. So let's come over here to the right, and we'll just make kind of a really informal graph here. Let's say this is our y-axis, and this is our x-axis. Okay, and let's say we have some graph that looks like this. Okay, it could look like many things. It looks like this. And although we're not talking about functions in this video, you may have heard of a function. Just call this, name this y equals, we'll express this as f of x. This is our graph. So the x-intercept is the point where the graph crosses the x-axis. Now, and so the y-coordinate of the x-intercept is 0. And also to find the x-intercept, set y equals 0 and solve for x. We'll take care of that in a moment. But here, let's think about it. So the x-intercept is where the graph crosses the x-axis. And so let's see where it does. And also, says a function can have no x-intercepts meant across the x-axis at all. It can have one or it can have more than one. So it's pretty open. So where's the graph cross the x-axis? Well, right here. And also right here and here. Okay. So these 3 points are what are known as your x-intercepts. Now, what about the y-intercept then? So the y-intercept, in similar ways, where the graph crosses the y-axis. Okay, and we'll go ahead and read this. We'll explain this more in a moment. It says the x-coordinate of the y-intercept is 0. So to find the y-intercept, if you're given the function or the formula for the graph, then set x equals 0 and solve for y. And a function, something called a function, can only have one. Can have a. Oops, this is actually a typo. Let me go back over here briefly. Let me go ahead and correct this. A function can have no y-intercept. If it has a y-intercept, it can only have one at a time. And that goes back to the meaning of a function. And so where's this graph cross the y-axis? Well, right here. In this case, this is our only y-intercept. So once again, if a graph is a function, not all graphs are functions. A graph's a function, you can only have at most one y-intercept. But a graph can have as many be a function, can have as many x-intercepts as you want. You can also have none of either. Okay, so that's what an intercept is. Now, let's practice then with actually finding the x-intercept of given functions. So I'll just here to say find the intercepts. Okay, so let's look at our example number 1. Now let's do a basic one. How about we do y equals x plus 2? Okay, so that's our graph, and it turned out to be a graph of straight line. We'll actually look at this line in a moment on a program called Desmos to make sure we're doing it right. But so if we want to find the x-intercept, actually let's find the y-intercept first, though it doesn't matter. Find the y-intercept. Well, once again, what we do then, look back at our graph. We said the y-intercept is where the graph crosses the y-axis, and on the y-axis, x is 0. So to find the y-intercept, we just make x equals 0 and plug that in. So if x is 0, what we have then is y is equal to 0 plus 2, or y is equal to 2. Okay, so when x is 0, y is 2 on the graph. And so my x-intercept, sometimes it's simply called y, that value, or it can also the y-intercept. I said that wrong. So this is the y-intercept. Sorry about that. Some people may simply say that y-intercept is 2, but the coordinates then are 0, 2. Okay, now let's come over here then and find the x-intercept. Or intercepts in general, though in this case there's only one. So once again, if we go back to our original graph, in the same way, we have an x-intercept when the graph crosses the x-axis. And on the x-axis, y is equal to 0. There's kind of a similar concept here. So we make y is equal to 0. Then we plug that in. So we make y 0. So this is going to be 0 is equal to x plus 2, and then get x by itself, solve for x. So subtract 2 from both sides. Then we have x is equal to -2. So some of that is simply called the x-intercept. But you'd like to write it in coordinate form. So the x-intercept, then the coordinates are x is -2 and y is 0. Okay, so if we made a graph of this, and once again, this is a straight line, we just had to plot those 2 points, and that would give us that would show us what our line looks like. So let's actually go to Desmos. So I mentioned this in previous videos. So DSMOS, graphing calculator. And what we want to graph then is y equals x plus 2. Now, you can see these are actually intercepts right here. So -2, 0, that's our x-intercept where it crosses the x-axis, as we just said, and 0, 2, where it crosses the y-intercept where it crosses the y-axis. Okay, so that shows that those are, in fact, our intercept, and those are only intercepts. Now let's look at one more example. This works for any kind of function, so you're doing the same thing. Let's look at one a little more. This has a little more going on. It's number 2. Let's do this. Y is equal to x squared minus x minus 2. Now, if you're familiar with this, you may recognize this. If you graph this, will actually give you a parabola. We'll actually graph this on Desmos here in a moment. But first, let's see if we can find our intercepts. So in the same way, let's find the y-intercept first. Often it's easier to do that one. So the y-intercept in the same way, the y-intercept is where x is equal to 0, where the graph crosses the y-axis, and on the y-axis, x is 0. So plug in 0 for x. So if we have that, we have y is equal to 0 squared minus 0 minus 2. Where 0 squared is 0. 0, -0 is still 0. In this case, we get y is equal to 2. So that's our y-intercept. Or the coordinates then of our y-intercept are 0, 2. And once again, a y-intercept, it's possible not to have a y-intercept at all, but if you have one, you can only have at most one. Then come over here and find our x-intercept, or possibly intercepts. You may have more than one. Actually, in this case, it turns out we do. So the x-intercept is where the graph crosses the x-axis, and on the x-axis, y is equal to 0. So plug in 0 for y. This means 0 is equal to x squared minus x minus 2. Now, this is actually what's called a quadratic equation. So in a future other video, you may see how we solve those. I'll go ahead and show you. So this one actually solved by factoring. So this side over here can actually be written. And we're not going to go into detail how to do this now, but you may see this in other videos. So this is actually the same as x. If you factor this, the same as x plus 1 and x minus 2. If you want to check that, if you multiply that, FOIL it out, or distribute, you get that. And then the rule here is that you set each one of these factors equal to 0. So x plus 1 is equal to 0. X minus 2 is equal to 0. And then just solve each one for x. X is -1. X is positive 2. So now in this case, we have 2 x-intercepts, one at -1 and 2. So our x-intercepts, we have 2 of them. So the first one is -1, and remember y is 0 in both cases. And then we also have 2, 0. Okay. Now let's go back to Desmos and graph this function and make sure that's what we have. Now, so let's just type that in. Y is equal to, also do a square any power, do x, and then use the little rooftop, which is shift 6, and then make power, then do the right arrow to get out of the exponent, and minus x minus 2. Now, if you don't want to leave a graph on there, like the red graph, the line, you can actually turn it on or off. This way you can turn this one on or off as well. It's by clicking that button. So let's turn it off. Okay. Now, talk about intercepts or y-intercept, we said should be 0. And let's go back here just a minute. I may have put, oops, I did. I'm sorry. No, I'm good. Realize I made a mistake, but that's a fixable mistake. It should have been a negative. Okay, so let me just write this better. Don't have much room. Sorry about that. This should be a -2. But I'm glad we saw that. That's one of the ways it's help you. A program like Desmo is helpful to make sure you get it right. Okay, that should be a -2. So that's our y-intercept. These x-intercepts should be this should be correct. So let's go back there, and that's what we see. Our y-intercept is 0, -2. Now we should have two x-intercepts. We do, where it crosses the x-axis. One is at -1, 0, the other one at 2, 0. So we see that's what we get. Okay, so what we just did is true anytime you want to find your y-intercepts or x-intercepts do exactly the same thing. Sometimes the equation you get may be harder to solve than others. That's certainly possible. But still, the process to find your intercepts are exactly the same. Then the last part, be able to identify the x and y-intercepts of a function's graph. Let's go back to Desmos really quickly. And let's actually remove this one. So, but I'll keep it. I can turn it off. So if I want to show it again, I don't have to erase it. Let me make another graph. Let's pick something you may not be familiar with, but there's just one moment here. Make sure my settings are correct for this. Okay, good. All right, y equals, if you're ever taking trig, or might take trig, something called a sine graph. Okay, now, if you haven't seen this before, not familiar with, that's fine. We don't really need to know the details of it. All we're thinking about here are intercepts. Okay, so think about our y-intercept. Remember the y-intercept where the graph crosses the y-axis and cross it right here, actually at the origin, 0, 0. And what that means, you plug in, if you're on the y-axis, remember x is 0. If you plugged in 0 for this, you actually get 0. Okay. Now, what about x-intercepts? Well, the x-intercepts the places where the graph crosses the x-axis. As we can see, there's more than one. Okay. For example, this point right here, pi 0 is an x-intercept where it crosses the x-axis. If you plugged in 0 for x, you'd find out that's gives you 0 or gives you pi. Here's another one at 2 pi 0. We have more over here. There's kind of a symmetry to this somewhat. Okay, wherever it crosses the x-axis is an x-intercept. And actually, this goes forever in both directions. So you actually have an infinite number of x-intercepts. Once again, to be a function, which this is, you only have one y-intercept. And so just remember, so if you want to find from a graph, find the intercepts, then the y-intercepts where the graph crosses the y-axis, the x-intercept or intercepts where the graph crosses the x-axis. And also remember, graph doesn't have to have either one. Let's do one more example quickly. Let's just do y equals x squared plus 2. Okay. Another parabola. In this case, we have a y-intercept. You notice we don't have an x-intercept. Because actually, if we zoom out and look at this graph never crosses the x-axis, so there is no x-intercept. I said you don't have to have either one, but if you have a y-intercept, you only have, but this is a function, so we can only have one y-intercept. You only have at most for a function, a graph that's called a function, most one y-intercept, but eventually have as many x-intercepts you want, or none at all, which is the case here. So what we've learned today then is look at our goals. So we want to understand what the intercepts are, we understand how to find them, and also understand how to identify the x and y intercepts from the graph of a function. Thank you. Have a good day.